Hi there. When I bought my Alumacraft boat, the trolling motor didn't work. The foot pedal to steer the boat or to adjust the direction of the trolling motor, it was all brittle. The plastic was destroyed from the sun and the motor didn't work. I plugged it to the boat, charged the batteries, and didn't spin. So I thought the motor is bad. And I shopped for a trolling motor and they're ridiculously expensive. They $700 plus for something same size, 70 pound. This the original trolling motor on the boat was 70 pound. So I thought to buy motors or a motor and replace the motor on my trolling motor and then delete the foot pedal and convert it to something like this. This is a small trolling motor. It will not run the boat, but I'm thinking about building something like this to control the speed and to steer the boat. I didn't want to mess with the motor at the time, the original motor, so I went on eBay and I found the guy was selling the same type of motor, this 75 pound. This has more power than the original. He had them listed for $99 a piece. I made an offer to buy two for $99 and he accepted my offer. So I bought these two. I bought a new prop and I bought some switches. I'm gonna come to those in a little bit. But while I was waiting on this motor, I decided to dismantle the whole trolling motor, including the original motor. And when I took it apart, I found there was two coils inside. And those two extra wires, they were attached to these two coils. And those will act as to reduce the voltage going to the motor, so that will give you different speeds. I was able to remove those two coils and just leave the two wires that go into the brushes that apply voltage to the armature. And this is very simple to take it apart. You just have two bolts over here and you pull this cover out and it has an O-ring over here to prevent water from getting inside. And also there is an O-ring over here and you will see brushes and all that. Unfortunately, I don't have any picture or video when I did that because I took it apart just to see what's going on. I wasn't planning to rebuild it. But everything was good. The bushings were in good shape. The seal were in good shape. So I lubricated everything, cleaned everything, put it back together, and the motor worked just fine. So I'm going to reuse the original motor and I'm going to save these for a future project. Now, the way I'm thinking about to control the speed, I thought of buying PWM voltage control or motor control to adjust the speed via potentiometer, but that's gonna waste some energy. To make it more efficient, what I'm thinking about doing, I'm thinking about using this toggle switch, which it has a 3 position: on, off, on. And when it's on off, the center tab or the common, it's not connect to anything. And when you switch it to one side, it will connect these two together. When you switch it to the other side, it will connect these two together. Each contact, this has 4 sets of contact. Each contact is rated for 15 amp. So that will make it 60 plus amp, the rating of this contact, which should be sufficient enough to run the original motor. I'm gonna build a handle that I could switch this to off, a 12 volt or slow speed, off, high speed, or 24 volt. And I think it's gonna work just fine. I also thought about using relays and have a button to either apply voltage to the 12 volt relay. These relay, they 12 volt, but the contact on them, it's a dry contact. So whatever voltage you put, that's what's gonna close. So I will make two of them. I thought about doing that, one for 12 volt and one for 24 volt, but I'm not gonna do that. I'm gonna go with the toggle switch. I also thought about getting a toggle switch spring loaded. There are some of them they call momentarily toggle switches, like this one. It's spring loaded, but I couldn't find one like this one here. This one will not work. It will get damaged because it's small. They also sell some toggle switches if you just want to build one for either a 12 volt or 24 volt. They have one where you could either off or on. But in my scenario, these motor, they all rated at 24 volt, even the one on the boat. So this is what I'm gonna do. I'm gonna try to use a 12 volt from one battery or two batteries in series, and that's gonna give me 24 volt. And let us get to it. I made this simple drawing to show how the plug for the trolling motor supply 12 and 24 volt to the trolling motor. And this is standard. All the boats that have 24 volt or two batteries for the trolling motor, they connected like that. Now be careful, I'm not showing the fuses. You're supposed to have fuses very close to the batteries just in case they're short, so you don't damage your wire or you not cause your boat to catch on fire. So be careful with that. This drawing shows the connection from the trolling motor male plug that connect to the boat to the toggle switch, and from the toggle switch to the motor. As you see, the center tab of the toggle switch or the common connect directly to the motor, and then one side has the 24 volt supply and the other side has the 12 volt supply. It's very important to use a flyback diode. Anytime you have inductive load on DC current, you're supposed to use a flyback diode to protect the switch from damage, because the reverse voltage of any inductive load, it could reach up to 10 times the supply voltage. So this will reach up to like 240 volt and it will damage the switch quickly. So you have to use a proper size flyback diode. The way this work is this bolt will fit inside this hole and it will lock everything together so the handle will move the trolling motor. I use rubber hose for the handle and for the bottom of the handle that connect to the pipe that go to the trolling motor, and I overlap it to act as a seal to prevent water from getting inside. And this is the flyback diode that I used. The original trolling motor stand had plastic pipe that helps support the stand on the boat, and it will also help release the stand easy when you pull the cable. However, it was deformed, so over here I'm manufacturing a jack bolt with rubber packing so it doesn't damage the carpet, and that helped me adjust it or fine tune it to make releasing the stand very easy. As you see, it's very hard to release the stand without that jack. The project was very successful. The trolling motor pulled about 33 amp on high speed, and it pulled about 12 amp on slow speed. I was able to use the trolling motor all weekend, 2 days, both Saturday and Sunday, without the need to charge the batteries. And on slow speed, the trolling motor go real nice. You could use it to fish on 12 volt. And if you want to travel fast, like if you fish under a bridge, you could go on 24 volt or high speed, and the boat will go quiet and fast. And at the end of this video, I'm going to show some pictures. It has more detail of the project in case somebody is interested. Thank you for watching, and enjoy these pictures and the music.